All right, more fun with graphing. Students in a physics classroom determined the resistance in an electrical circuit by measuring the voltage when a current was passed through the circuit. The table below shows the results. So our current running through the circuit in amps is our input, and our voltage in volts is our output. So we'll start off by graphing this guy. Now, in order to do that, we need to set up our scale. Our input axis, let's see, we're going up to 4. Let's just keep this simple. 1, 2, 3, 4. That will be our current. Make that C, which is in amps. Oh, they've made that I. How about we not confuse things? Let's make that I. There we go. That's staying in. Then our voltage V, which is in volts. Let's make that. That goes up by, gets up to 48. 10, 20, 30, 40, 50. Oh, perfect. So if each of these goes up by 10, that would get us to just above 48. Great. Now, we have our first coordinate. I'm going to write these out beside. Got 0.5 amps and 6 volts. So 0.5 is halfway between our 0 and 1. It's right here, and we get 6 volts. Right there. Our next coordinate would be 1.5 and 18. 1.5 is right here. 18 is up here. Just double checking that. 10, 12, 14, 16, 18, 20. Okay, that does work out. Perfect. And we'll just keep carrying that on. 3 and 36, that's way up here. 30, 32, 34, 36, yep. And 4 and 48, way up here. Does it make sense to join the points together with a straight line? Short answer, yes. We are dealing with continuous variable in this case. What that means is, can I have a current in between 0.5 amps and 1.5 amps? Of course I can. If you ever played with the multimeter and measured current and voltage, you can get any kind of decimal you want. So it does make sense to, this is going to be a totally straight line that I'm free drawing here. Yep, look how straight that line is. Nice straight line all the way through. It makes sense for us to have points in between 0.5 and 1.5. For the data we are dealing with, that is perfectly fine. Now, use the graph to determine the voltage for a current of 2.5 amps. So we've got 2.5 right here. I'm going to trace that up just using the graph, not an equation. To here, I'm going to bring that on over, should be at about 28, according to this graph. Now this line could probably be a bit straighter, but I think that's pretty darned close. 2.5 amps gives us 28 volts, according to our graph. It's called interpolating. We find our 2.5 volts, bring that up to our line, and then bring it over to the y-axis. Write an equation expressing V in terms of I. So what that means, we want V equals something I. Let's start with our rate of change. How much are we increasing how much is our voltage increasing for every increase of 1 amp? So this is not quite straight. This should be about 12, then 1 to 2, we get about 24, 2 to 3, we get about 36. So for every unit of current, every amp I'm increasing by 12 volts. So wherever I take my amperage, and if I multiply that by 12, I should get my voltage, according to the graph here, which, yeah, it should be a straighter line. Use the equation to determine the voltage when the current is 6.2 amps. So then using this guy here, now just to jump back to D for a second here, how did I get that 12? Well, it's really just doing a rise over run. If my run here is 1, then my rise here is 12. Another way I could look at that is, this is my slope right here, and my slope is equal to rise over run, which is 12 over 1, which is 12. We could also do the same thing, but with a longer stretch here. If this is 24 here, and a change of 2, that would be 24 volts over 2 amps, which would give me, again, 12. So use the equation to determine the voltage when the current is 6.2 amps. Voltage, we've got V equals 12. I am squishing everything in here. This is foolish. We'll make sure I'll write this later. Times 6.2. Just plug that into the old calculator. Should give me 74.4 volts. Once again, just taking the equation and substituting in. The resistance, R ohms, is calculated from the equation V equals IR. State the resistance in this electrical circuit. All right, this seems like a trickier question than it really is. We've got voltage is equal to IR. If you've taken some physics courses, you might already be familiar with this guy or done some electrical work in your day. All right, so we've got an equation of V equals 12I. Interestingly enough, we've got the I matches up, the V's match up here. So it's I times 12 gives me my voltage according to the equation I've built here, which I got from the graph. So V equals IR. What am I multiplying I by here? R. Look at that. R is equal to 12. If we wanted to get fancy, we could also rearrange this formula to solve for R. Some people like doing it this way. Could just divide by I on both sides. In that case, R is equal to V over I, which, look at that, that's our rise over run, which we already did the work on over here, which is equal to 12, our slope. So the resistance of this circuit is 12 ohms. It's just fun drawing the omega sign there, really. There we have it.